Welcome to Google I/O.
Disability, increase your latency more fast. Application with processing, storage, and cacheable resources. Reaching browser, radio, and audio, and uploading your geolocation API enabled faster on the go. Right, your multimedia location service with regular JavaScript. Experience, dynamic images, drawings, and drag events. Independent partnership, performing computation, check communication, APIs, and multi-origin post events. Maintain pixel file service, execute workers, and cross-domain messages. Experience, dynamic images, drawings, and drag events. Independent partnership, performing computation, check communication, APIs, and multi-origin post events. Maintain pixel file service, execute workers, and cross-domain messages.
Ladies and gentlemen, please welcome Chief Executive Officer of Google, Dr. Eric Schmidt.
Thank you. Thank you all. First, let me start by welcoming everybody. Many of you traveled a long distance to come here to spend 2 days with us to talk about the thing I like the most, which is programming. And let me tell you that it's time. It's time for us to take advantage of the amazing opportunity that is before us. And that's what I want to talk about for just a few minutes. Today and tomorrow, you're going to have interesting product announcements, some fun stuff, and perhaps most important, you're going to spend time with the best programmers in the world who are here in the room, literally you all. And we're very excited to have you here. From my perspective, it's time. We have spent 20 years trying to build a programming model that's the right one. We started with the mainframe model, then we moved to the PC model, and it had brilliant parts and very frustrating parts. And then the internet arrived. And internet programming, the way we think about it now, is something we have all worked on for all of our career. It's time. Why is it time? We finally now have the networks, the businesses, the programmers, the programming tools that can build the kind of platforms and the kind of opportunities that I want to highlight. Today and tomorrow, you're going to hear a lot about some of the Google technologies many of you are already using. For example, Google Web Toolkit. We used to say write once, run anywhere with Java back in my old job. Now it's write once and run on any browser, right? Because the browsers have become so complicated. That's what GWT is all about. We're going to see a lot more things about a product called App Engine, which now today includes, by the way, support for Java, right, which is great, and more presumably coming. The notion of these platforms as powerful platforms are part of a story that's been true forever. And it's a story that innovation always occurs elsewhere. It never is in the little world that I sit in or that you sit in. It's always somewhere else. There's always a programmer, an inventor, a brilliant person who's somewhere other than where you are. They need to use a platform that you build. They need, for example, to be able to use a platform even if they don't speak English. And even if they don't really understand some of the other things that you've done, but because they have an idea and they have a vision. And maybe they use the wrong operating system or they have the wrong background or whatever, but they're clever and they're smart. And that's how innovation occurs. It's always been true and it will always be true. And that's why we're here today. Maybe you're here to talk about Android and some of the things that we're doing there. Android looks like it's going to have a very strong year. Not only do we have many thousands of applications now as part of our Android application store, but we also have many hardware partners that are coming along to build innovative new hardware platforms which look like phones but do a lot of things that are not normally associated with phones. Again, the innovation cycle continues. So what we want you to do is we want you here to spend your time with our teams and vice versa and yourselves with each other to try to figure out what we can do now. So why is it time? Why is it time? Why is it time to take the challenge? Because people are frustrated. They're tired of the complexity of all the systems that have been built up over the last 10, 20 years. They don't work that well. Where's the It Works option? Where's the button where it just installs and works? Why do we keep adding complexity after complexity in our world? Well, here's an opportunity using AJAX programming, the new programming languages, the new programming paradigms that we're going to talk about in the next couple of days, to build another step higher, to bring another level of functionality that ultimately means power can generate simplicity, and ultimately make these systems simpler and easier to use by the people we serve who are not programmers. They're not computer scientists. They're not engineers. I'm one of these people who believes that computer science is at the center of the universe. I'm one of these people who believes that what we do as scientists, as programmers, as people who care about making the world a better place, can really scale. I'm a person who believes that scalability and the power, as evidenced by the power of the internet, is just beginning. And I would tell you that we're just at the beginning of getting this right. When we talk about cloud computing, we talk about all the new kinds of devices, you're seeing a whole new set of companies, ideas, product solutions, competitors, all sorts of things, all coming from this shared vision around a new programming model. It's not the old programming model where I was handed a book and said, program against these interfaces against this standard OS, and everything will work locally. But it's a similar model where I can go pick the very best of this code and that code, put it together, mash it if you will, have it automatically compiled, and have it deliver tremendous performance for all of us. With this, we can take the collective intelligence of the internet, which is astounding, all that information, all those things going on, and do amazing things. We can tell people what's going to happen. We can tell people what's happening nearby. We can follow what they care about. As you walk down the street, we can tell them the history of the buildings as we walk along. We can do image recognition to sort of see what's happening. All of these are applications that someone in this room has already built. All of you are busy building the version 2 of all of those kinds of things. It's phenomenal. So my message to you is this is the beginning of the real win of cloud computing, of the real win of applications, of the real win of the internet, which is changing the computing paradigm, the one that we've all grown up with, so it just works. And it works no matter what device you're using, whatever operating system you're using, as long as you're connected, and even if you're not offline with some caching, you're on and you have everything you need. That's the promise of our new web computing model, which we're all talking about. We're going to show you some amazing technology and some amazing partnerships that we've done in the next hour and a half. I'm delighted that you're here, and I'm excited about what we're doing. And I want to take a minute to thank you for coming and also introduce Vic Kondrata, who's the executive who's in charge of all of our developer programs, all of our mobile programs, and lots of our businesses. Vic, can you join me on stage? Thank you very much.
Thank you, Eric.
Appreciate it. Thanks.
Thank you.
Thank you.
Thank you for those opening comments, Eric, and good morning, everybody. Welcome to I.O. Never underestimate the web. It's a mistake that I once made. It was about a half a decade ago, and I was leading a team at Microsoft responsible for driving the developer adoption of Windows. Of course, we had seen the emergence of the web, but we argued that web apps could never rival desktop apps. In fact, our favorite and our canonical example was from a small Bay Area company called Keyhole. Keyhole had made the most fantastic geo-visualization software for Windows. And it was exactly that kind of software that we argued could never be done on the web. In November of 2004, Google acquired that small company, and a few months later released maps.google.com with satellite views, a web app that simply left us stunned. Maybe you remember the first time you, from any browser, were able to zoom down into your own backyard. You know, Google Maps was amazing, is amazing. But what was even more important was what that application was foretelling. That we would see what we formerly thought was impossible become possible, even commonplace in the browser. Yes, the web has won. It has become the dominant programming model of our time. In many respects, this conference, Google I.O., is about a celebration of that open web platform. And this morning, I'd like to talk to you about the ongoing evolution of the web, of making a more powerful web made easier. And this morning's keynote is broken up into two broad sections. In the opening section, I'm going to show you what's making the web more powerful, some new HTML5 standards that are enabling us to build applications that I think will surprise users. And in the second half of the keynote, I'm going to highlight some Google services that we believe can help you build those apps much easier. So let's get started here. Let me find the clicker. You know, I think when you look back over the last year, in fact, just the last 8-9 months, you have to be amazed at the rate our web platform is accelerating. It seems like almost every other month we've had a browser released, even either for the desktop or for mobile. And these new browsers are not just faster. I mean, of course they're faster. But even more importantly, these browsers are incorporating net new functionality that, frankly, I'm not sure most developers know about. This new functionality that's included in these browsers allows developers to have their cake and eat it too. we still get the best of the web browser deployment model, that friction-free deployment. And for the first time, as developers, we're able to access the underlying services, such as geolocation or the graphics subsystem or storage or CPU services, in a way that was formerly only limited to native applications. And those capabilities, we believe, will close the remaining gap in usability and performance from native apps and web applications even further. Of course, it's not just about the technology. It's about people. It's about the people in this room, those who've contributed to this amazing acceleration of innovation that we've seen. This chart is the unique monthly contributors to open source projects. And just look at the growth of our community of developers contributing to make the web better. And so it's no surprise that as our community grows, we see more innovation. I mean, let's just stop for a moment. Did you realize that in the last decade, we have seen a 100x improvement in JavaScript parsing? Think about the implications. The implications are that what we thought was impossible to do in the browser with JavaScript may now become possible. Of course, that's just one example of technological improvement. We're going to show you lots more today. The community growing, more innovation has led to the ultimate metric of success, which is users. And today, we have almost 500 million people who are using modern open source browsers. And I think that is just a fantastic testimony to the success that we as a community have had in moving the web forward. I'm going to walk you through some new capabilities in what I'm going to broadly categorize as HTML5. We believe that the capabilities that I'm about to show you in this keynote allow us to move beyond Web 2.0 apps, but really move to kind of apps that have capability, have a fidelity, have an experience that I think will surprise you. Before I go into those new standards, I want to tell a cautionary tale, and I want to plead for help from you. Almost a decade ago, I was on another team responsible for driving the adoption of XML HTTP request. It was a new capability we had added to the browser that allowed for asynchronous callback. And I talked to many companies, many developers, and we just didn't get traction until, do you know when? Until about April of 2004, when Google released Gmail, and we saw an explosion of AJAX apps. Yet those underlying capabilities that enabled those AJAX applications had laid dormant in the browser for over half a decade because no killer apps were developed that exploited those capabilities. I'm going to plead with you as a community. Let's not make the same mistake again. As we talk about these new standards this morning around HTML5, recognize that having the capability in the underlying platform is not enough. It's up to you and people like Google, companies like Google and others, to build the compelling apps that are exploitive of these capabilities. Let's not wait another half decade. Let's take advantage of these things that you'll see this morning. Let's build those exploitive apps. Let's move the web forward even faster. So this morning, I'm going to invite up Matt Waddell to walk us through. We're going to go through about 16 demos this morning. You're going to see a lot of the capabilities we're talking about. And Matt, my colleague, is going to walk through these demos as I talk over them. We're going to emphasize 5 things that excite Google and we think you should be paying attention to in the HTML5 world. The first one is Canvas. Let's talk about the problem. You're developers. How do you draw a diagonal line in the browser? Think about it. What do? Draw a diagonal line in the browser. Well, I know you'll think, well, Vic, I guess you can't really draw a diagonal line in the browser. You would draw an image on the server, you'd push the image down, and you'd get your diagonal line. Yeah, you're right. But then, of course, your interactivity is limited to the granularity of the image tag. That's not very interactive. Some of you in the audience are going, wait, it's easier than that. Just use VML or Silverlight or Flash, and you're right. Those approaches could work. But what if we wanted something that was part of the open, transparent internet that we know and love? And that's exactly what Canvas is. The Canvas tag is intrinsic. It's native. It fits seamlessly into the page and works great with JavaScript and CSS and the DOM. And Canvas allows you as a developer for the first time within the browser to have drawing and animation APIs with pixel-level control, which changes the kind of applications we can deliver. Let me show you. In the first example we're going to show, we could switch to the demo machine. Matt is just going to draw within the browser, and he's using the mouse, and he's drawing. The magic here is in the source code. That's the entire source code. There are no plugins here. What's magical is what Matt is highlighting. There's the use of the canvas tag. And then the JavaScript is doing nothing more than responding to mouse up and mouse down movements. And he's drawing right there within the browser. Let's show you a little bit more advanced example. This is a first-person gifter. We did this on Mother's Day, and we thought first-person shooter was not politically correct, so we changed it as the weapon. I guess he runs around giving gifts. But once again, the magic here, look at the JavaScript. It's the use of the canvas tag and nothing more than JavaScript. And this is amazing. That kind of demo a decade ago was amazing on the PC. Now you can do that within the browser. This next example is Bespin. It's a development tool from Mozilla Labs. It's an IDE that allows you to build web apps, and it's a fascinating tool. What's interesting about the IDE is that it feels like a native app. It's not a native app. This is in the browser. And the use of canvas tags to do pixel-level control gives this Bespin IDE tool a level of richness and a native feel that I don't think you're used to in the browser. Finally, let me show you another example. This is an internal tool. We have never demonstrated this publicly. We've never shown this. It's a tool we use at Google to do profiling of characteristics, and so we can tweak our apps and make them faster and better. So we can switch to machine 2. And what Matt's going to do is, this is running in Chrome. He's going to click on the tab, and he turned on this profiling tool that you see him moving to the right. Now he's going to open an article in the New York Times. And I don't think you clicked on that article. There we go. Now, as he goes to that article, what will happen is that profiling tool will start to graph the performance characteristics of that particular operation. Note how he can zoom into that profiling tool. Those spikes represent time or things that are slowing down the app. And as he moves up and down, he can see the various events. Matt, can you click? There we go. So he opened up a script tag. You can see the pie chart there that shows what % of the time was on the JavaScript compile, what % was on parsing the HTML, and so forth. So the tool is interesting. But would you believe that tool is completely built in HTML5? That's just the use of the canvas tag to produce this level of high fidelity? It's an example of the kind of apps that we as a community can build once we have pixel-level control on the screen. Let's go back to the slides. Of course, one of the advantages of using something like Canvas is that you, as the developer, get to take advantage of performance improvements in the browser. So as JavaScript continues to get faster, you get to ride that rocket and automatically benefit from that. Of course, we've shown you some examples of Canvas to produce higher fidelity apps in 2D. Is the web ready for 3D? Well, we think it might be. In fact, I'd like to invite up Matt Papakipos up to the stage to show you some 3D demos and some emerging standards that we think will surprise you. Matt.
Okay, you gotta go, right?
We've lost Matt. Aha, there he is. Okay, Matt, please.
Thank you, Vic. So I'm Matt Papakipos. I run one of the efforts in the Chrome team at Google. We're very excited about the prospects for 3D graphics inside the web browser, and we'd like to share with you what we've been working on today. Over the last 10 years, we've seen an explosion in 3D content that real users use every day. Everything from video games to engineering applications to data visualizations like Google Earth. What's been missing thus far is the ability to run these 3D graphics applications in the browser itself. So let me show you what we've been working on. This is O3D. O3D is a project that we've developed at Google that we open sourced a little over a month ago today. You can find this on code.google.com. So what are we looking at? We're looking at rich, interactive 3D graphics running in the browser. It's a JavaScript API that a conventional web application can use to get 3D graphics functionality whenever you want in your app. As you can see, we're running it here in Chrome, but it also runs in Firefox and IE and Safari and Opera. The application we're running is what we call our beach demo. It's one of the many code samples we developed for O3D to make sure that the technology worked and performed. And it's open sourced on code.google.com. So the full source code of the JavaScript and all the art assets are fully open sourced. So you've probably seen graphics like this before. in games or in other applications. What you haven't seen is seen this running intrinsically in the web browser. So the technology clearly has great potential. Let me walk you through some of the interesting aspects of this demo to show you more about it. So first off, notice the visual quality here. We have very high-resolution texture maps on the surfaces of the rocks, of the trees, of the bottom of the seafloor under the water, and of the sky itself. We also have what are called bump maps. So we have detailed textures on the surfaces that describe the local surface texture, the physical shape of the surface, which gives us very realistic lighting as the light bounces off the scene and hits the viewer. We're also doing some very advanced shading techniques on the water. So you can see that we've implemented reflection and refraction. And these are coded right in the source code of the application, so the application can control the visual appearance of the water or other attributes of the scene. The next thing that we focused on was performance. So you'll notice we're running at a smooth 60 hertz here. It gives it this very smooth, liquid feel, like you're really there, you're in the scene. The same level of performance that you would expect to see from a native application running on the operating system. And here we're seeing it in the browser. The other interesting aspect is we're doing all of the graphics on the graphics processor, on the GPU. So the CPU load, as we run this application, is less than 10%. So the CPU is still there for you to use in your JavaScript code and by the browser to implement your application logic, which is extremely important. And then the last point about the demo that's interesting is it's all JavaScript code. So you have all the nice attributes of JavaScript for web development. You can edit the code right on your machine, test it on your machine, deploy it easily. No complicated build process, it's just JavaScript. So this is very cool technology, but we still have a long way to go until we achieve our dream. What we want to get to is the point where you type a URL in the address bar, go to a website, and play a rich, interesting 3D graphics application. In order for this to happen, we need this capability to be built into the browsers by default. So we need a common set of APIs that are implemented widely by all the browser vendors so that your browser of choice does this intrinsically. It becomes a feature of the browser itself. The key here is standardization. So we at Google are working very closely with Apple, Mozilla, Opera, and others in the context of the standards organizations to make this a reality. So we still have a ways to go, but we've begun the process of standardization for how 3D graphics will work on the web. And we invite you to join that discussion. The other thing is we have to put it in the browser itself. And so we're hard at work at Google integrating 3D graphics capabilities like these into the Chromium code base so that Chrome has the ability to do this without the need of any plugin whatsoever. So we're very excited about the directions this is going. So this is all very cool. It looks neat. It's very fun. It's nice to see the web gain these capabilities. But it's still just a demo. We're still in the very early phase. This is a plug-in today. We're very excited about the future. The other key to the puzzle here is applications. We want to see real-world applications emerge where you and people like you make applications and websites that use these capabilities to their full advantage. What is the next killer 3D graphics applications on your website? Is it a game? Is it data visualization? Is it an engineering application? Is it something new? So we're very excited about the prospects for the future, and we hope you will check it out and join us in pushing it over the finish line.
Obviously, if you'd like to learn more about what Matt just showed you, there's the URL, and you can get all the details, in addition to the sessions that we're having on it. Going back to the Canvas capability, remember, developers are not going to use Canvas if it isn't broadly available. And we're very happy to report that across all modern open-source browsers, Chrome, Firefox, Safari, we have this capability. I hear some of the laughter. You must be wondering why I didn't mention Internet Explorer. Let me talk about that briefly. Obviously, Microsoft, with its very large market share, could do much to move the web forward. And so you can imagine how excited we were to hear Microsoft's public statements about their commitment to the HTML5 standards. And that very, very much excites us, and we eagerly await to see evidence of that. That's all I'm going to mention about IE today. Now that I've danced past that elephant, let's move on. Let's talk about video. Just like I asked you with Canvas, let me ask you with video. How do you play video in a browser today? You know, as a developer, you really have a tough job. You got to ensure that your users have the correct plugin installed in their browser. In addition to having a plugin installed, you've got to ask yourself, does that plugin support the appropriate codec that video is encoded in? And there are some variables that are outside of your control as a developer. So video is hard. You might ask yourself, if you were responsible for moving the web forward, what would Occam do? Well, how about a video tag as simple as image? That's exactly what HTML5 video gives you. A simple tag where you point it to the source and the browser handles the rest. Let me show you some examples. Let's go to machine 1.
Billy's been trying to customize his web browser.
This will make it go faster.
Okay, that's one way to make the web go faster. It's a video playing in the browser, no big deal, until you look at the source code. And you look at the source code here, and you can see use of the video tag to play that video, and nothing more than JavaScript to play and stop it. Of course, because it's integrated right within the browser, let's go back to that demo. One of the benefits is I can start a rotate. This is just a simple JavaScript, CSS, transform, and look, I'm rotating the video. I can even play it if I wanted to. But it gives you a sense of the advantage of using something that's intrinsic to that web programming model. DOM manipulation, just like any other element with the video tag. Let's go on to the next demonstration. This is an experiment. We are not announcing today that YouTube is going to be built this way. This is a demo that we just wanted to show you to get the creative juices going. Obviously, YouTube is a site that you no doubt know and love. This looks like YouTube. In fact, there's one change that's pretty significant, which is if you actually look at the source here, it's implemented using the video tag. And because it's implemented using the video tag, those videos play, and they're intrinsic to that HTML page. You see as he mouses over the thumbnails, they just play. Those are not 1, 2, 3, 4, 5, 6 plugins. I'm not marshalling across boundaries. This is JavaScript, the video tag, and that's it. And it kind of gives you an example of where we might be going in the future. All right, let's go back to the slides. Once again, very happy to say across modern browsers, broad support has been implemented for the video tag. Now let's talk about geolocation. At Google, we believe that almost all kinds of apps could be better if they had access to geolocation. Everything from business software to social software. And think about your CRM software if you're a business. When your sales agent lands in Denver, why doesn't the CRM software recognize his location and show him or her the current customers based on proximity? In social software, why isn't the photo automatically geotagged? Why aren't my updates, my tweets automatically tagged with location? Well, the reality is that accessing location and using it is hard today. You might think, what about GPS? GPS takes a long time to get a fix. GPS may often not work indoors. What about IP-based location? Well, it's too fuzzy. It's not granular enough. I mean, heaven forbid your users are AOL users, where the IP has gone through a proxy in Virginia and all the location reports is Virginia. And so it hasn't been possible to get good quality data sources until the last year. Companies like Skyhook, companies like Google, and others have created large databases of Wi-Fi data and cell ID data, and really have mapped the entire world with coverage. These sources, combined with GPS and other sources, have now given us the ability to accurately triangulate or pinpoint an individual's location with their consent. Of course, you might be wondering, well, that's good, that's great, Vic, but how do you get it in the browser? Well, guess what? The last year, we have seen tremendous progress with standardization of the W3C geolocation API, which is implemented in these browsers. So you, as a developer, can take advantage of these capabilities. To demonstrate these and kind of talk about them, I'd like to invite up Jay Sullivan, Vice President from Mozilla. Jay, welcome.
Thanks, Vic. Good to see you.
Jay, just one moment before you go into your presentation and demo here, I did want to take a moment and just say thank you to the Mozilla community. To a large extent, we have the luxury this morning of talking about modern browsers, about HTML5 standards, about evolution. But in reality, I'm not sure we would have had this luxury had it not been for Mozilla's and the community's phenomenal work over 10 years. There was a time when people wondered if the odds were against you guys, with competitors that had the benefit of pre-installation. But you guys really proved that you could build a community of hundreds of millions of loyal consumers who chose Firefox, and you could build a better web. So for all that you did, for what you're doing now, and for what you will do, thank you.
Thanks, Vic.
Thank you.
Well, I want to thank Vic for that introduction. Not for myself, but on behalf of the whole Mozilla community around the world that's made that possible. It's an amazing, vibrant, crazy organization that it's fun to be a part of. I want to do three things today, real briefly. I want to explain why Mozilla is here at I/O. I want to talk about what's coming in Firefox for developers, and I want to give you a brief demo of geolocation support in the browser. So, browser competition is heating up again. That's no secret to anybody here. And we think this is very important. As users live more and more of their lives online, it's very important that we continue to improve the user experience, to make the browser faster, and to protect users' security and privacy online. And we see what happens when there isn't any competition in the marketplace. Things stagnate, there aren't new features, the web does not get better. Now, since we entered the market with Firefox and other browsers have followed, these modern browsers that we're talking about today, that's improved the user experience. So it's very important to have that vibrant competition in the marketplace, and we're glad that these other folks are producing browsers. Now, it's also important to note that each of our organizations have very different missions and motivations for why we work on web browsers. But today we put all that aside to focus on what we share in common. So we share, I think, three important things in common. One, we believe strongly that the web is the development platform for our time. More than any single operating system, the web is going to drive the innovation and the new services that are going to do amazing things for people all around the world. We also share a belief that we need to keep bringing new capabilities to you as developers so you can create these things. And that means that we need to move quickly. But also, we need to make sure that we don't fragment the web. There will be no worse outcome than through this renewed competition to have a fragmentation of the web platform. You should be able to focus on building your house and not worrying about the cross-browser plumbing. So we need to work together to keep that standards held together. And that's a challenge. And it's the web, so it's messy, right? So we don't always agree on what the perfect API is to expose a new piece of functionality. We don't even always agree on the process to run some experiments and then decide which the best API should be. But I strongly believe that a very, very good API for something that's in 5 browsers is better than a perfect API that's in no browsers or one browser. So we need to work hard together with Google and the other browser vendors to hold that center, and that's very important. I want to talk a little bit about what's coming in Firefox 3.5 for developers. Now, Firefox 3.0 is the most successful browser that we've ever built. We have about 300 million users worldwide. We just recently had our 1 billionth add-on download. So Firefox 3 has been phenomenally successful. But we believe Firefox 3.5 is better. We believe it's much better. JavaScript performance, which is the underlying piece that enables all of this innovation and these apps that we're working hard to build. JavaScript performance is 3 times faster in 3.5 than it was in 3.0, and 10 times faster than it was in 2.0. So we've been working very hard to increase the speed of JavaScript execution. You heard a little bit about how Canvas works and how video works. And what I think is important here is getting things like video out of plugin prison so that we can script them. And when you combine things like video and Canvas, as Vic demoed, you start to see the power of being able to use things through web APIs and be able to manipulate them and mash them up in new ways. And that's really a common theme for some of this new functionality is it's the web. You should be able to touch anything, hack anything, and mash up anything. We're adding support for geolocation, and I'll talk about that more in a minute. We also have support for offline storage, so that you can begin to write apps that work better when they're disconnected. And that's very important for mobile situations and other use cases. And we're also adding support for web workers so that you can write scripts that run pretty intensively without hosing your browser. Very important feature. And all this stuff is you can look at the link up there and go there, and it'll take you to a description of how to use these new APIs, and exactly what the level of support is in Firefox 3.5. I want to talk a little bit now about geolocation support in the browser. So in Firefox 3.5, there's support for the geolocation API, and I'm going to give you a demo of one of the apps that's going to use this. So we believe that there are use cases in many spheres for geolocation support. We think it's going to change how maps, local search, directions, all sorts of social networking, anywhere where you want to tag something with geolocation. We believe it's going to change the nature of how all of those applications work. One particular application that's going to take advantage of Firefox's support for geolocation is Google Maps. So Google Maps shortly will be adding a new button to the user interface called My Location. And if I click this button, I get a prompt, and I get request if I would like to share my location with that website. I'm going to go ahead and click share. I'm going to come back to this because I want to talk about this a little bit, but I'm going to go ahead and share my location. Couldn't be determined. Let's try that again. Okay. Murphy's Law of Demos. So I wanted to explain what's happened there. So what happened when I clicked that button was the browser gathered up the signal strengths of all the nearby Wi-Fi hotspots and transformed that into a latitude and longitude. If it was a cell phone, I could have used Wi-Fi, or I could have used cell tower IDs and the signal strength of those that are nearby. I could even use GPS if it's local to the device. So there's a number of ways a back-end provider can enable that functionality. And because it's Firefox, user choice is important. So users will be able to download all sorts of add-ons that are going to provide that back-end location functionality. And web developers can enable their applications with just a couple lines of JavaScript code. It's dead simple to use the API. I want to come back to one thing real briefly, though, which is how a user opts in. 'Cause I think this is very important for features like this that begin to blend services with client-side functionality. Now, when I click the button, I get this modeless info bar. Now, don't try to write down the URL. It's not going to work. It's behind some Google firewall. Don't try this at home yet. But I get information about what domain name is requesting my location. I can click Learn More if I want to understand how the service works and how the privacy policies work. And if I just ignore this, nothing happens. If I close it, nothing happens. If I hit Don't Share, and I can remember that not sharing so that I don't get prompted in the future, any of those things, and my location is never accessed by the browser. It's only if I explicitly opt in, and that has to happen on a per hostname basis for this to work. So we're trying to err on the side of the user being in control, even though it might include an extra click here and there. We think it's important to err on that side. So that's it for the demo. We look forward to see the great things you're going to do with geolocation and with all of these features. So thanks, Vic.
Thank you. Yeah, we love those guys and can't wait to see what they're going to do next. Geolocation, broadly available in modern browsers. Before we move on, I should show you one more geolocation demo. Jay mentioned the importance of using geolocation in mobile scenarios. We've got exactly one of those demos to show you. What you're looking at now is Latitude. Latitude is an application Google released several months ago for phones like the BlackBerry or Windows Mobile or Nokia phones. What you're seeing for the first time is Latitude on the iPhone. And there's even one more surprise. It's Latitude on the iPhone in the browser. And the reason this is possible is because in the next generation of Apple's operating system, they too have implemented the W3C geolocation API, so we're able to build apps that were formerly impossible, now possible, right on the web, on the platform. You'll see this app shortly after Apple releases OS 3.0. Okay, let's go back to slides. And by the way, that's another evidence of Google making the bet on HTML5 and really trying to build those flagship apps so we can move the web forward. Now let's move on and talk about app cache and database. As much as we love web apps, they don't work in many situations when you lose connectivity or have intermittent connectivity. And there are a lot of scenarios that we wish our web apps could work. One of the challenges is that there's no local storage and no way to store the application state or code. That is until recently. What the HTML5 standards of database and app cache allow you to do is really approach the problem of offline, or even in the online scenario, store and cache the resources you need for a faster application. Let's show you how this works. Let's go into the first demo. First demo, I'm in Safari. I've got a little app. It creates a sticky note, and I can create some sort of data. And if we go into the developer tool here, inspect the element, go into the database, you'll see that sure enough, the notes I'm writing are pushed down into that SQLite database. But let's lose the connection. Okay, no connection, no Ethernet connection. Can you go to google.com? Okay, good. My favorite website is inaccessible. We really are offline. Let's try creating another note. Okay, so the note continues to work. The JavaScript's all there. The data is being pushed into the SQL database. Now, you must be wondering, okay, you've got the data in the database, but where is the app? Well, let's look at the manifest, because the standard points us to a way to actually have pointers into the storage system which point to where the code is, the JavaScript code, and the other resources that you need. And so there you can see where the JavaScript, CSS, images, and other things are stored, so that when you're in an offline state, you can rehydrate all those resources, and the app just works. Let's show you a more advanced example. This is an Android phone. And what you're looking at here on Android is Gmail. It's really, really rich Gmail. You can see the colored labels. For those of you who are Gmail users, you've come to know and love. As Matt moves around, you see that floating toolbar that moves with him. That's all implemented in this particular app, and it's very, very fast. You click a message, it opens up. Here's the kicker. Look at the top of the screen. This is an Android device that's in offline mode. It has no connectivity. In fact, what you're looking at is a web app utilizing the great new capabilities of the Android browser to have support for these HTML5 standards. This particular app, Gmail on Android or on the iPhone, is already shipping. In fact, it's Google's first big HTML5 app, and really demonstrates the power of what's possible. And as these phones get faster, these web apps just get better and better and better, whether it be better JavaScript performance, or the CPU of the phone gets better, or the network connectivity gets faster. These really become more and more capable. And another example of Google moving towards HTML5. Okay, let's go back to slides. Of course, we're not the only company who's really has invested in the web. Another company that has pivoted their strategy around an open web platform is Palm. And to talk about that, I'd like to invite up Michael Abbott, Senior Vice President of Palm. Welcome, Michael.
Thanks,
and I think Michael and Greg are going to talk about this. Yes.
Thanks a lot, Vic. Good morning to everyone here. I think that one of the interesting things that I was thinking about yesterday is that if it was a year ago and you were at this conference, I'm not too sure many of you would have predicted that Palm would be at stage here at Google I/O. And one of the key things I think why we're here is that we share a very common vision, or similar vision. And that is indeed that the web is really the platform. And as we step back in time from when we were designing and architecting webOS, we were thinking through how could we actually enable developers to have a programming model that we're used to, but at the same time offer access to both services in the cloud as well as on the device. And so what we did was we have built up a platform with the browser as really the core construct, and more concretely actually using WebKit as the core rendering engine in webOS. So all of the core applications that are built as a part of webOS, Mail, Contacts, and Calendar, are all built in HTML, CSS, and JavaScript as applications in this environment. So if you look at a little more details of what one of these applications really look like, you can see that we have an HTML page that defines the layout of the application. We have JavaScript which can define transitions, animations, access storage on the device. And we might use CSS to style the applications. Now, for developers, we have a framework called the Mojo framework that allows you to style applications in beautiful ways and at the same time be very performant. Now, with this programming model that we're offering, certainly standards is really important to us. And HTML5 is a really key aspect of webOS 1.0. And so we're going to show you just a couple quick demos of how we've actually deployed and leveraged HTML5 in the initial version of the platform. So we'll switch over. So the first I'm going to show you is just an example of the canvas tag in our calendar application. You can see the way we're using it is to actually get really high-performance scrolling, as Greg actually scrolls up and down in the day view. So that's just one example there. The next example we're going to show you is CSS transformations. So this is in our music application, and you can see that we're using CSS transformation to rotate the album art. Again, this application is all built in HTML, CSS, and JavaScript. And the last example I'm going to show you is with HTML5 database. And we're using that HTML5 database as a mechanism to store users' history as well as browsers. Now, within this development environment, there's a set of services that are on the device. We'll get to the next slide. That we want to offer and expose up from the hardware in this particular case into that development environment. And the accelerometer is one of these extensions that we'd like to see in HTML5. What we've done is offered up various events into that JavaScript runtime. So, for example, events around shaking, acceleration, and orientation, and expose those events up through a DOM level 2 interface into JavaScript. Now, there's certainly other types of events like this that, as a result of that deep integration between the software and hardware, makes a lot of sense, certainly for the mobile computing platform. And that's actually one of the key things that we're interested in working with you on over time, which is how do we actually really bring in both the mobile and the desktop development environments together. If you look at an example of how we're actually doing this type of integration of the applications using these Accelerometer API, you can see that we define a set of events, and then you as a developer can go and define the handling of those events. So depending on how you want to leverage the accelerometer in your application, it's very simple to access these events and leverage these within that JavaScript programming environment. So again, what we see for HTML5 and webOS is really a key convergent point between the mobile platform and the desktop platform. And we're very interested in working with you over time to extend all the various events and access services from these hardware platforms into this runtime. Thank you.
Thank you. Thank you. Okay, App Cache database broadly adopted today in these browsers. Finally, let me talk about web workers. You know, as the web becomes more powerful and you build better and better apps that become richer and bigger, you do run into some problems that native applications have solved. For example, any of you who've written applications with large amounts of JavaScript understand the challenge of having the UI freeze as you do JavaScript parsing. It's not pretty. But unfortunately, it's unavoidable as your JavaScript gets larger and larger. How do we solve this problem? Well, in a native application, you could spawn a background thread. You could have background processing. And that's exactly what the HTML5 standard of web workers allows you to do. Let me show you some demos. Let's move over to screen 1. There we go. This particular example just calculates some prime numbers. And so we've got a couple of tabs open there. You can see we've got the New York Times and so forth. Matt, why don't you go ahead and start the demo, and now try clicking on another tab. Exactly. So the JavaScript parsing is completely hosting not only the tab, the UI of the tab, but as well as the rest of the browser. Let's redo that demo. This time, let's look at the source. Same demo, but look at the source. We made a change. And you see there Matt highlighting the use of the background processing via the web worker. Let's run that same app again. Number one, the UI is responsive. The other tabs are responsive. And it all just works. Right? New capability, background processing in the browser from JavaScript. That's just really, really great. Let me... Hold your applause if you like that. Wait till you see this. This demo is my favorite. Okay, it's using the canvas tag to place the boxes. It's using the video tag to play the video. It's using JavaScript and web workers to run some background processing. Let me tell you what's going to happen. We're going to start the video, and you're going to see a lady walk by the video on the video. JavaScript is going to run and do motion detection and then draw via canvas a bounding box around the object that's moving. And it's going to do that in the background, so the app's still responsive. Watch this. The boxes in the right are differentials. How crazy is that? Did you ever think you'd see background processing, you'd see video motion detection done in JavaScript in the browser? You know, I certainly didn't. This is just fantastic and a great demonstration of these capabilities all coming together and the kind of rich app that we can now start to build within the browser. So I hope you like that. Let's go back to slides. Very good. And once again, that capability broadly available in these modern browsers. So I hope you've enjoyed that section of the talk. That was about a more powerful web and how, as an industry, we are creating new capabilities, but it's still up to us as a community to build the applications that take advantage of that more powerful web. I'm going to pivot at this point and now talk about making it easier to build those kind of apps and how Google services can help you. Obviously, if you came to last year's developer conference or attended any of our Google Campfire ones or watched them online, you know that Google's deeply interested in making it easier for you to build web apps. Two of our offerings in this space have been Google App Engine and Google Web Toolkit. Google App Engine's value proposition was very simple. We said, let us provide the hosting for your app. So you don't have to worry about machine instances. You don't have to worry about the app scaling. You don't have to carry a pager. We'll do that for you. And we're going to give you an update on that in a moment. Google Web Toolkit had a different proposition. It said, write in Java, and we'll compile down, understand which browser is being used, and push down the appropriate JavaScript, and do it in a fantastic way that allows you to target multiple browsers. To give you an update on Google App Engine and Google Web Toolkit, let me invite up Andrew Bowers and Kevin Gibbs. Thank you, guys.
Thanks, Vic. You know, the interest and adoption that we've seen in Google App Engine over the past year has been truly remarkable. We've had over 200,000 developers sign up to use Google App Engine. And not a single one of those developers had to purchase or provision a server to get started. They were able to develop their application locally on their own machine, be it Mac, Windows, or Linux, and leave the servers to us. Now, our SDK is just 3 megabytes. If you haven't tried out App Engine before, I encourage you to download it. Give it a shot. Now, since we launched App Engine last year, we've also had over 80,000 applications deployed on Google App Engine. Now, often these applications have been created by small and agile teams, like many of you in the audience here, and they can be, because with App Engine, you don't have to worry about your configuration, your uptime, or usage spikes, or re-architecting your application once it finally starts to get popular. In fact, we were able to put this policy to the test ourselves when the White House decided to use Google Moderator, which runs on Google App Engine, for President Obama's live town hall event. Despite a traffic peak of 700 requests per second and promotions on all the major search engines and news sites, the application scaled to meet the traffic, and none of the other applications were affected. Now, over the past year, we've also launched a number of features and improvement to App Engine, including things like our SSL support, Memcache API, the system status site, access to secure data behind the firewall, and the ability to pay for usage beyond our free quotas. Now, we've also found that there's a number of additional things that we'll launch to you in the coming months. They include things like background processing for your jobs and large object support for your application. If you'd like to learn more, I'd urge you to come to our sessions here at Google I/O over the next 2 days. Now, certainly the feature that we've launched recently that's generated the most noise and the most buzz is our Java language support. The interest in our Java support since we launched it a month and a half ago has been remarkable. In a matter of days, even hours since we launched our Java support, we saw developers, many of you in the audience here today, dive in and get not only Java frameworks working on App Engine, but also other JVM languages, including things like JRuby, Groovy, Scala, and even PHP. And that we thought was truly amazing. I'd like to say thank you for all of you early adopters who gave us a try and gave us some feedback with the system. Now, we found that the demand for Java on App Engine has been so overwhelming and the response so positive, we think that we're ready to take the next step with Java on App Engine. So I'd like to announce, sorry, I skipped the slide. I'd like to announce that we are opening signups for Java on App Engine as of right now. Anyone can now log in and create a Java application immediately. Thank you. Now with that, I'd like to stop telling you about our Java support in App Engine and start showing you. So I'd like to pull over Andrew Bowers. Andrew is going to demonstrate to you how we have an end-to-end solution for creating Java applications using Google Web Toolkit and Google App Engine. Andrew's going to demonstrate to you how we think we have a way to make applications both more scalable and easier to use, with backends running on Google App Engine and front ends built with Google Web Toolkit. Andrew?
Thanks, Kevin. So if any of you have ever done Java development, you've probably experienced the frustrating lag between getting a development environment set up and actually deploying something to the web. And if you're working on a weekend project, maybe you decided to go ahead and use something like Ruby on Rails because you wanted to actually get something out there. So we definitely recognize that pain and frustration in our own lives and tried to make the on-ramp to a new app as quick as possible. So to demonstrate, I'm going to create the starter project from the Eclipse plugin. I'm going to deploy that to the web. And I'm going to use Google Web Toolkit and App Engine, and hopefully it should take me about 2.5 minutes. So somewhere around there is my goal. So here I have the Eclipse development environment, and let's just get started. I'm going to go ahead and open up the new project wizard. I'll create something called Google, create a package. And I'm going to use Google Web Toolkit and App Engine. And this is going to create the starter project for me. Oh, looks like we already had something running. We'll go ahead and stop that. And now I'm going to start that on a local server. So this is has everything I need already. I didn't have to install Tomcat. All I did was I installed the Google plugin for Eclipse into my Eclipse development environment. That downloaded the App Engine SDK, the Google Web Toolkit SDK, and the local development server, which mimics the production environment. So now I have a very simple AJAX application. It takes some text here, asynchronously sends that to the server, echoes the text back, as you can see, and then gives me a little information about the server that I'm running, just so we can tell that it's actually going to the server. So if we look at the code for that, open up the project here, you can see I have a client package and a server package. Now, all of the code inside my client package is Google Web Toolkit code that's Java code that's going to be compiled into JavaScript in the final step. And it's using widgets and it's using events, so they're abstracted away so that it'll work across browsers. So I could change the text on the button here to post. Inside my server package, I have Java classes that are going to run as bytecode on the server. And you can see that I'm getting an RPC, and I'm echoing it back. So we'll say hello from Google I/O. We'll save that there. Now if I go back, so I've just edited Java code. I'm going to go back to my browser. I'll click refresh. And I see it says post, and I see it says hello from Google I/O. So I just edited Java, but I'm seeing those changes now in my browser. OK, so I've got a small functioning app. Let's go ahead and deploy that out to the web. Go back into Eclipse. I'll go up to the deploy wizard. And you'll notice there's an error here right now. That's because I haven't set an application ID. So I'm going to go to the App Engine console, and I'll create a new application ID. We'll say demo for I/O, and we'll save that, and hope no one beat me to it out there. So OK, you're not fast enough. Great, so we'll go back. I had some backups just in case. So we'll set the application ID here in the environment. And all I need to do now is enter my username and password. Then hit the deploy button. The SDK is taking care of the rest for me. So it's going to convert that Java code from Google Web Toolkit in the client package to JavaScript. It's going to compile the Java code to bytecode for the server-side stuff, package all that up into a web archive directory, and deploy it to the server. There's no FTP involved by me, no server configuration. Everything's handled within the SDK. And I could do this from the command line if I wanted to as well. And so now we should have a deployed app, and hopefully within a few minutes here. So let's go to that demo for io.appspot. And so I've got a fully functioning, if not very functional, app out on the web. So remember, too, that was in Java and it was really quick. There was no server configuration. There was very little development configuration. Just installed Eclipse and installed a plugin, and it's pretty much ready to go. Also notice that I didn't have to write any JavaScript XHR calls. That's because I'm using Google Web Toolkit, and it'll handle the communication between the client and the server for me. So what App Engine does on the back end, making server-side tasks easier, Google Web Toolkit does on the front end, making client-side coding and development easier as well. So if we can go back to slides. So they told me I needed an architecture diagram. So it's Google Web Toolkit in the front and App Engine in the back. Now, I want to talk about two features that are coming up in Google Web Toolkit. We're optimistic that HTML5 is going to bring some sanity to the browser world, yet you're still going to have to develop for multiple browsers. Now, Google Web Toolkit is inherently designed to work across browsers, handling the differences for you. So you write your user interface in Java, and then the compiler is going to handle the compiling to the optimized, appropriate JavaScript for each environment. But right now, there's a wrinkle in that development flow. We encourage people to use CSS because it's a powerful way to style your apps, but if you're familiar with this, you'll also know it's frustratingly inconsistent. I see some of you relate. So it's times like these when you want to use Firebug to figure out what the heck's going on. Now, here's the wrinkle. Because we have real-time Java debugging in Google Web Toolkit using a special browser, it's meant you had to compile to JavaScript first, then take that, go view that in Firefox, and then look at Firebug. And then so we had an extra step in there. Well, I'm happy to say in the next version of Google Web Toolkit, you'll no longer have to do that. You'll be able to debug directly in the browser. It's also not just Firefox, it's any browser. So let me show you a quick demo of what that looks like. So I'm going to go back to the project that I just created. And I'm going to change the launch configuration to use the new plugin. So we'll take this out here. So this is going to start up the plugin infrastructure. And I'm going to close down nightly and start up the other version of Firefox we have here, because that's what my plugin is installed on. Now I can navigate to my local server. And you'll notice that I'm passing in a special query parameter so that we know it's coming from the hosted mode. And you can see this is the app that I just had. And so now I can use Firebug and inspect like you're used to. Okay, well, that doesn't seem too special, but remember that what I have on the back end is still Java. So you can see this is Java that we're generating here. I can make that change, go back to Firefox. I'm not using the special browser here. Click refresh. And then I should be able to inspect that. Well, let's see if we refresh again. Or sometimes it helps to restart your server. So let's do that. All right. So we've got that running. And make sure I didn't cache. So this is going to make the development cycle a lot faster. It's also going to work on multiple browsers as well. So all the major browsers have plugins. And there we go. There we see some changes. And it'll also work with other plugins as well. Now I want to talk about one more feature that we're really excited about in the next version of Google Web Toolkit. With all this HTML5 functionality, you're going to find yourself writing rich user interfaces. And if you've built apps like that before, really large JavaScript, AJAX apps, you'll know that your JavaScript code base is going to grow. And it's going to grow a lot. If we can go back to slides, please. It's going to grow a lot as you add more functionality. And that in turn means your users are going to wait, and they're going to wait, and they're going to wait for your application to finish loading. So you need a way to split up all those JavaScript files across multiple files so your user can get started with your application without having to wait for it. However, manually splitting JavaScript can be very tedious. You have to get the dependencies correct, it takes a long time, and it's not something you want to do on a Friday night. So that's why in the next version of Google Web Toolkit, we're going to help you out with that and do it for you with something called developer-guided code splitting, also known as run async. Now, with run async, what you do is specify in your code somewhere that you're willing to accept a short pause in exchange for the compiler being able to functionally fragment your code base. So what this means is I can download code after the initial download. Imagine you have a settings page. It's rarely used, not used on startup at least. Well, there's no reason to download that code with your initial download. Instead, you'd set a run async split point, then allow that code to download in the background after your user is up and running. Okay, you're saying, Andrew, that's great in theory, but does it really work? Well, I'd like to leave you with some metrics from a real-world application that's using run async. This is an application we'll talk more about tomorrow. This is a graph during development of the size of the JavaScript code base. So it quickly grew to 1.4 megabytes as they added more functionality to the UI. So that's a lot of code to download on initial download. Now, after run async, the initial download was decreased to 200K, which can then be decreased another 80K to about another 80K when you gzip it. So 1.4 megabytes to 200 kilobytes, so that's about a 7x decrease. It's going to load a lot faster. And the best part is they didn't have to worry about the dependencies themselves. The compiler looked at their code base and handled all that for them. So these are just a few of the features that we're adding to Google Web Toolkit. We're going to be talking a lot more about the future and the present with both App Engine and Google Web Toolkit over the next few days. So please stop by and join us. Thank you. Thanks.
Great job, guys. And as you can see, these are the URLs where you can go to learn more or attend any of the sessions. Of course, we are very, very happy at Google to see the developer adoption of Google services. You go to a web page and you see someone who's incorporated Google YouTube or Google News or Google Video or even Google Search on their page, and it delights us. We have over 60 APIs that we make available to developers. In fact, we're very proud to announce today that we have crossed the 4 billion API threshold. That's 4 billion API calls every day coming into Google. That's even a big number for us. And so thank you for your support. Thank you for enhancing your apps with Google services. Of course, we're not satisfied. We want to do more to make your web apps better and make the web even richer. And we looked at one of our most successful models, and that's AdSense. There are literally hundreds of thousands of sites that use AdSense. And they get those Google ads on their page by nothing more than including a little bit of JavaScript. And so we asked ourselves, why couldn't we take that approach for everything we were doing? Why not make our other services that easy to incorporate into your applications? To demonstrate a brand new developer product for you, I'd like to invite up DeWitt Clinton to walk you through that. DeWitt, please.
Hey,
welcome.
Thank you, Vic. Hi. Today, I'm very pleased to introduce Google Web Elements. Google Web Elements bring Google products to your website using simple copy and paste. We were inspired by the embeddable YouTube video and AdSense and asked ourselves, could we apply this approach to more products? Today, I'm going to demonstrate adding Google News and Google Maps and Google Search to a website using Google Web Elements. Let's get started. Here's a simple website we put together. Standard 2-column layout, like something you'd find on Blogger or WordPress or your own site. It looks pretty good, but I think we can make it more dynamic. I'd like to pull in headline news from Google News, and I'll do that with a Google Web Element. I go to google.com/webelements, and I select the news element. And here I can choose from headlines from technology, sports, politics, or enter my own. I'll enter Google, and I'll fit it to my site. And I copy the code, and I go to the HTML of my site, and find the right place, and I hit paste. When I go back to the page and refresh, Google News is already live. I'd like to add now a map to Moscone and the developer conference. So I go to google.com/webelements. I go to the Maps element. I type in Moscone Center. And we're here for Google I/O. And I like the terrain view. And again, I copy the code. I go to my template, and I paste it in wherever I want. Refresh, and we're already live. Now, even a small, thank you. Now, even a small site like this one can benefit from search. I can do that with the Google Custom Search element. I'll go to google.com/webelements, click the Custom Search element, and right now, I don't need to do anything more. The Custom Search element will automatically configure itself to search just the content of my site. So all I have to do is copy, and I think you're seeing the pattern here. Paste, and the search box appears. I'll do a test search. Looks good. However, since the custom search element is built on top of the Ajax search APIs, I can apply the styling rules and custom JavaScript however I like to make it fit my site. I move the search box over here, and there we go. So I've added maps, news, and search all in about 3 minutes. And my site's certainly more dynamic, but I'd like to make it more interactive. I'd like to make it social. I can do that with the Google Conversation element. The Google Conversation element allows visitors to my site to post comments and videos and hold a conversation about whatever topic I choose. So in fact, I will choose Google I/O as a topic. And I will copy the code. I will paste it into the site. And I will refresh. And our conversation is live. Hello, Google. Oops. Google I/O. So we've seen, just using copy and paste, adding search, news, maps, and conversations to the website thanks to Google Web Elements. Google Web Elements are available today at google.com/webelements. Thank you. Thank you, Vic.
Copy-paste development. We think that's really going to make it easier. Next, I'd like to talk about Android. Eric mentioned it in his opening remarks. We couldn't be happier with the progress that we've made in a little over just half a year since Android's been introduced. In those brief few months, we've had 3 versions out, including the latest version last week of the Android 1.5 SDK. We've had 10 carriers and available in over 12 countries. Over 4,900 apps, almost 5,000 apps, including apps like the one we demonstrated on Android earlier, using the powerful capability of its browser. And on average, we're seeing users of Android download over 40 apps to their device. And so the ecosystem is really working. Browser share is just fantastic and fun to watch. And we thank you for your support. What we'd like to do next, though, is show you a sneak peek into what's coming next on Android. And for that, I'd like to invite up Raman G. Raman, please, why don't you show us what's coming next?
Thank you, Vic. With Android 1.5 now live, the Android team is already hard at work on the next version of Android, and we codenamed it Donut. You may have heard of it on the web already. And today, I want to show you 2 exciting new features that will ship as part of Donut. First, we want to make search more useful and more powerful, both for users and developers alike. For users, we want them to be able, from a single query, to be able to search the web, their contacts, their bookmarks, their application, and their music. But let me show you what it looks like. So here I have an Android device. And on my home screen, when I click the search widget, I can initiate a new search. And if I start typing, the device automatically looks for my applications or my contacts. We can also look for web results. So if we're hungry for pizza, and the 3G is working, we can search the web for that. But we decided that the search UI could be a lot more than that. The search UI can also act as a brand new launcher for you as a user. Every time I click a search result, the system remembers what I did with that search result. And the more I use my device, the more the device will know about me, about what I do every day, about my common tasks. And what happens is every time I start a new search, I get pre-populated results. So here, for instance, last time I did a search, I clicked the calendar application, and I see here the result that matters to me on a day-to-day basis. So this is going to be an awesome feature, because I know that in this part of the UI, I will always have access to the thing that matters to me as a user. But there's more. We want this search UI to become a powerful tool for your applications. And with just a few lines of code, your application can populate more results in the search UI. And I have a simple example here. I wrote an application for myself. It's just a list of books I've read. And I wanted to be able to quickly search my library from the home screen. So with just a couple lines of XML, I'm now able to add my search results to this UI. And if I type the name of one of my favorite authors, I can see his books appearing in my search UI. And you can see search results from the web, more books, and more web results. So we're really excited about this feature because you guys are creating the content. You have the application. You have content that the Android platform doesn't have. And we can't wait to see what you're going to do with it and what you're going to put in this UI. Next, we wanted to add a new API, something that you developers have widely requested. In Android 1.5, we introduced a new speech recognition API that lets you control the device without any physical interaction. Now, the problem is the device cannot interact with you. So we're introducing a new text-to-speech API that lets the device, read text to you or give you results or, turn-by-turn navigation if you're writing a GPS application. And I have a simple demo here. We modified the translate application that you can find on the Android market, and we added the text-to-speech API. So for instance, here, if I want to translate a sentence from English to French, and I click the translate button,
Bienvenue à San Francisco.
The device reads the sentence to me. And we're shipping, we're going to ship Donut with several voice packs for different languages. So in any language, the user will get the right accent, so they will be able to understand what the device is saying perfectly. So for instance, in German,
Willkommen in San Francisco.
Or even in English. As you can see, we have two different versions of English.
Welcome to San Francisco.
So we're really excited. We're really excited about these APIs because we know that you guys are going to do great things with it. But it gets even better. We're shipping a new text-to-speech API in Donut, but we're also going to ship the text-to-speech engine. And thanks to SVox, that engine will be open source. So as part of the Android platform, any Android device will have an open source text-to-speech engine of high quality like you just heard right now. Finally, I want to show you a small experiment that we've been working on in the Android team. We recognize that sometimes finding a specific item in a long list of data, for instance, I have several hundred contacts, and finding one item in that list can be, pretty painful. So we have different solutions to address that issue. We have search on the home screen. You can filter your list when you're in a contact application. We have a fast scroll widget, many different ways to do it. But we wanted something new, something more interesting, and that was a little more fun to use. So I have a small demo for you here. Wouldn't it be cool if I could just launch my contact application and start drawing on the screen to filter my list? And I can keep going, and the device just recognizes the handwriting and filters the list. Instead of filtering, if you prefer, you can simply jump to an item. So for instance, in the music application, I can jump directly to a certain position in the list. We care about the user experience, but we also care about the developer experience. And we hope that with those new APIs that we're introducing in Donuts, there will be more, you are going to come up with awesome applications that will make Android a more exciting platform. Thank you, Vic.
Thank you very much, Ramon. Well, folks, we covered quite a bit of ground. First of all, you heard about our call to action for HTML, Google's commitment to make applications that are HTML5 exploitive, and we hope you join us. We talked about App Engine being opened up for Java signups. We gave you a sneak peek at GWT and what's coming next in the next version there. We introduced Google Web Elements, copy, paste, development. And finally, we gave you a sneak peek at what's coming next in Android. We have 3 more things and 1 final slide. First, I'd like to announce that we have part 2 of the Android Developer Challenge being announced today. The details are located at that URL. We will take submissions for the contest in August. Judging will occur through the fall, and we'll announce our winners at the end of fall. This time, we've learned a few things from American Idol, and so we will have user votes as part of the judging, and we think this contest is going to be really, really exciting. Number 2, I'd like to announce that we're going to give away to every conference attendee today, all 4,000 of you, this box, which contains a link to the SDK, documentation, and a few more surprises, including an Android phone. I think, we realized that you could go download the SDK, you could use the emulator, but nothing beats having a real device. And I've always wanted an Oprah moment. So for you and you and you, there's one more thing. This is an unlocked device that'll be available. In addition, we went 1 step further. Included in every device will be a SIM that gives you unlimited 3G data and thousands of hours of calls for 30 days. And so we realize some of you don't have a SIM to get started tonight. You might have a CDMA phone, but we think this is a nice way to get started on you exploring the platform. It's our small way of saying thank you for supporting our conference as well. I'd like to conclude by just making a few more quick announcements. If you thought that surprise was fun, we have another surprise for you. Please don't miss tomorrow's keynote. Tomorrow's keynote, I think, will surprise many of you with some exciting things that have not yet leaked, and we're so excited about that. So you'll enjoy that. Number 2, picking up your device. You can pick up your device starting this afternoon throughout the entire conference. So you don't have to go rush. You don't have to go queue up in line right now. Go to your sessions, and in the afternoon at the registration area, we'll start giving out all 4,000-plus devices. And we'll continue that through the party tonight. So don't miss the after-hours party. We're going to have some great DJs. Like last year, we're going to have a lot of fun. And, of course, many Googlers will be there to interact with you. So once again, thank you for attending the keynote. Enjoy the conference, and thank you for supporting Google I/O.
Welcome to Google I/O.